And without any further delay, I would like to introduce our next speaker from PBARC, underneath the United States Department of Agriculture, Pacific Basin Ag Research Center, Dr. Lisa Keith on controlling coffee leaf rust in Hawaii. Lisa.
Well, thank you, Chris, and thank you, everyone. Sorry, yep, same thing. I'll try not to put my back towards anyone, but here to talk to you specifically about coffee leaf rust and controlling it in Hawaii. And, coffee leaf rust has been on the planet almost 150 years. It is managed in other parts of the world. There's a lot of literature and information we can pull from. And I've tried to summarize what is working and what works here. Okay, so before I start, you've heard the overarching theme of cooperation, teamwork, and that is exactly with these types of projects. Thank you so much to the growers, our cooperators, the university, the various industries, agencies, and I give an incredible shout out to my group working in the lab in the field, and you see all the smiling faces really trying to help solve these problems. Okay, so really to start, as a plant pathologist, explain, well, how does disease happen in plants? And it seems pretty simple. We talk about the disease triangle, needing a susceptible host, a pathogen that can cause the disease, and the right environmental conditions. But in actuality, this is a very complicated process. Everything needs to happen at the right time, at the right moment, to actually get disease. So if there's a way to minimize or actually eliminate a portion of the triangle, we can start managing or controlling disease. So coffee leaf rust, that's the disease caused by the obligate parasitic fungus, Himalaya vastatrix. Well, that seems fancy. What kind of fungus is it? It actually needs the living host to survive, and coffee is its only host. Essentially, a spore starts the infection, which leads to the production of more spores and more infections, and that process continues quite a number of times in the same cycle. So on the right side here, it will show you, and so it's important to know as much as you can about the fungus that you're trying to control. And this will be a little more evident as I show some of the control measures further in the talk. But you can see that, sorry, I don't know if there's a, but the picture of the powdery spores on the underside of the leaf, okay, that's what the spores look like under the microscope. And that one spore essentially will get onto the leaf surface. Now, Himalaya vastatrix will only germinate under the right environmental conditions, the right amount of moisture, typically at night, on the underside of the leaf, okay? It enters the natural opening of the coffee leaf, the stomates. So it'll actually germinate and enter into the stomates, and then because it needs the living host to survive, kind of taps into the host system, produces very formal structures so it can start feeding off of the host. It then grows back outside of the stomates and starts to produce structures that produces hundreds of thousands of spores, which then easily spread around and can start new disease cycles. So the disease does vary depending from season to season based on the environment, particularly rainfall. Okay, so how does the fungus get around? Well, these spores can travel in the wind, but probably more importantly here, through water splashing and physical transport. And you saw what that spore looked like with those almost like Velcro-like structures on the outside. So it attaches to vehicles, it can attach to people, it can animals, and spreads quite easily that way. Again, the infection occurs through the stomates on the underside of the leaf. Now, why is that important? In order to get to it, to manage it, the sprays have to get to where the fungus is, okay? Water, again, is necessary for germination. So there are ways to cut down on the moisture that remain on the leaves. You can help manage the issue. And of course, unfortunately, the temperatures here really are conducive to disease. Now, it develops very quickly. It sporulates. Once it germinates, it gets inside. 2 weeks, 3 weeks, you can actually see symptoms and the initiation of spore development. Now, survival of the pathogen is mainly inside the leaf. Okay, I'm going to talk about why that's important. The spores themselves can survive maybe about 6 weeks on their own, but if they don't get to another living host, they'll not continue their life cycle and essentially die. Okay, so for early symptomology, well, it's important to know what it looks like early so you can manage and use the right tools that we have. Okay, the upper surface. So it's interesting that you see the spores on the lower surface, but actually the first spots are visible on the upper leaf surface. Why? Because again, it's drawing the nutrients, the energy, so chlorosis or this yellowing starts first. Then the underside of the leaf is where you see those powdery spores. So the symptom can actually be anywhere that the stomates are, okay? But this is not on a leaf vein, and this is important when you start to look at different diseases, okay? There's no pustule formation. You may hear, oh, rust form a pustule or a depression. That's not the case with this fungus. And so these signs, so different, the symptoms are how the host responds to pathogen attack. The signs are actually looking at the fungus, and those are those powdery yellow spores. Okay, so some differences between a disease that's been here, not really causing a whole lot of issues, called Cercospora spot, caused by another fungus, Cercospora coficola. The major differences to look for. Cercospora spot, immediately you will see brown or necrotic centers in very small spots. You will not see this with coffee leaf rust. The undersurface, because this fungus can go in, it basically barrels its way in, produces toxins. You'll see sometimes depression, discoloration very early. You see no destruction of the leaf tissue due to hemolea. It remains smooth, then the powdery spores form. Okay, so look for leaf veins in particular. Cercospora spot can happen on the veins, coffee leaf rust cannot. Okay, so it has to be managed as a continuous epidemic, okay? The goal is to reduce sporulation, spore dispersal, spore infection. This, for one disease, management, the health of the plant is critical. And really, it's the understanding of, well, how can you make the plant its healthiest? Susceptibility of the plant, so it's interesting, you want to fertilize well, but too much of certain elements are detrimental when it comes to disease. So nitrogen and phosphorus can actually reduce susceptibility, but excessive potassium increases susceptibility. So it's good to know, the overall tissue and your elemental concentrations. And so anything to cut down on that water. So wider spacing, good pruning, getting rid of weeds, improving the air circulation. Again, it needs at least 24 to 48 hours to germinate. So if the moisture is not there, that will not happen. Okay, weed control, again, cuts down on not only the competition of the nutrients, you can promote then soil health, air circulation, drying of the canopy, okay? Now, because of where the fungus is inside the leaves and the spores on the leaves, you want to do sanitation, okay? So exactly what Andrea is mentioning, fallen leaves, if possible, remove and destroy. Use the proper available fungicides. Again, yes, the guide's awesome, and label is law. Okay, you heard our friends at HDOA, label is law. And then, yes, potentially resistant cultivars, and you'll hear some more information shortly. Okay, so we've done a lot of fungicide testing, starting in the lab, actually, to see if products can kill spores, how to prioritize what we can test in the field, the types of assays we do, just to show you under the microscope, the germination of the spores, and we want to stop that. So we want to try to find things that actually look like that bottom right, no germ tube formation. Okay, the first thing, we wanted to make sure the sanitation methods being recommended using alcohols or bleach are effective. And that's what these charts, the graphs are showing you. The products on the bottom, the percent germination on the other axis. You want to see no color to show that, yes, 70% and higher, super effective at killing spores, and a freshly prepared 10% solution of bleach. Okay? We've partnered with Julie to kind of get a glimpse of her field trials and what it would look like and how effective the products are, particularly the systemics at killing spores. Also, what was registered for use, we wanted to see how that would look. And then, we're always getting our hands on other products, maybe friendlier chemistries, to see can we find something just as effective. Okay? So in the field, we could now actually do some rotational sprays, looking at the biological products, starting with oxidate, using products like Serenade and double nickel, the coppers, and ultimately, the take-home message is management is possible. It may not actually decrease germination of the spores there, but overall incidence and very low severity. So it is possible to manage with healthy field, healthy tree, and good rotation of available products. Okay. Another study we're doing is actually applying the fungicides to see how much protection it will offer. When a spore then lands, well, how often then would you need to treat? Okay, so some of this information I just wanted to cover quickly, just to give you, again, where the fungus exists deep within leaf tissue or germinating on the underside of the leaf and why it's important to get good coverage. Okay, so the contact fungicides that you've heard, protectants, they pretty much are where you put them, where you spray them, there they are. They're not moving through the leaf material. There typically are few problems with resistance for these types of products, but it's a low residual. Typically higher doses are needed and more applications. So that picture just describes, well, if a spore lands and there is that protectant on the leaf surface, germination will not occur. But if it's not good coverage, germination will occur. Okay, so onto the systemic fungicides. These are also preventatives, curatives, okay, absorbed into plants. Now, there's a big difference. The true systemics are mobile throughout the entire plant. That's the upper right. You apply the product, it moves in the xylem, the phloem, into new leaves, full protection, okay? The difference, translaminars. Translaminar essentially will travel from one side of the leaf to the other side of the leaf, okay? That's the big difference. So yes, you'll hear systemic, but a translaminar systemic is different than a true systemic fungicide, okay? But typically, high residuals, lower doses are used with fewer applications necessary. but a greater chance of resistance, which is really why you need to continue your rotation. Okay, so another picture. The blue drops are the spray of the chemical and where it goes, how it moves, and are new leaves protected. Okay, so that's just the example on the left with the contact or the protectant. Essentially, the droplet will hit, spread out a little. Well, if the spore lands on that fungicide spot, it will be inhibited. If not, germination will occur. And again, it's critical to get the spray coverage on the underside of the leaf where the fungus is going to germinate and enter into the stomates. Okay, so the middle picture is that local systemic or the translaminar. It definitely gets good coverage of whatever leaf it hits, but it does not offer protection for the new leaf material. And the true systemic here on the right, you see at full movement going up and down the plant, including into the new leaf material. Okay, just to reiterate, the protectant has to be where the spore lands, okay? The translaminar here on the right, if that leaf is protected and germination will then occur, protection with some curative effect locally. The true systemic, wherever the spore germinates and tries to grow within the leaf material, that's where you see the curative properties. And that also carries into the new leaf growth. Okay, there's a whole nother topic of the biologicals. The biologicals typically are bacteria, bacillus species, that are in the products that compete for space on leaves. They compete for the nutrition, the food source. There's also secondary metabolites that these bacteria produce in the products and perhaps in nature too. Things like antibiotics or toxins that then go after your microbe, your pathogen. Okay, variety testing. I'm not going to say a whole lot because our expert's going to follow up with this, but we do a lot, again, in the lab to try to get a first glimpse of the material. Is it worth really looking at? And when limited resources and people power, how can we prioritize? So we've really scaled up and partnered with a variety of people, including HARC. This is just showing you what these leaf disc assays look like. The left being a highly susceptible, the right showing good resistance. Now, sometimes you'll actually see kind of a defense response, sometimes you won't, and we're really looking for that side of the spectrum. Okay. My personal favorite, sometimes you may notice there are some fungi growing on the coffee leaf rust spores. And these are potentially fungi attacking Himalaya. So we're trying to isolate them, identify them, and actually see if they are true fungal parasites that can go after our pathogen. Then how can we use them as another tool? Okay, so I really want to reiterate that there is no magic bullet. There's no one thing to do to combat coffee leaf rust, okay? There are long-term solutions, short-term solutions, things like definitely scouting early, seeing things early, maintaining your plant and soil health, good hygiene, good sanitation, the potential of resistant varieties, but just because it's resistant doesn't mean management can stop. We definitely want to avoid the introduction of races. We have one race here. We don't want that evolving to a lot of races. So it definitely is a challenge, but we're trying to attack it from all angles. And so thank you very much. If there are questions, great. I will then also introduce our next speaker. But I want to reiterate, Andrea's website is a plethora of information. Awesome. Go check that out. And thank you to our funding sources. Thank you very much. That's a great question. So is there a prediction model? And that will not really be addressed today, but another specialist, Dr. Melissa Johnson, is working on a model like that. So there are models that exist for other parts of the world, and she's really trying to collect enough data to make that happen here in Hawaii. Okay, so great question. When the spores fall off the bottom side of the leaf, essentially what happens? Well, the individual spores, if they reach the right place with the right time and conditions, they'll start a new disease cycle. But the spores that come off, the fungus is still inside. The pathogen continues to grow and multiply and sporulate on the outside of the surface. That's why, okay, within, the month, 300,000 to 500,000 spores are produced. They go somewhere else or they're washed off. The fungus is still inside, and it will sporulate again under the right conditions. So that's why it's so challenging. I mean, the one spore ends up with potentially millions of spores in a very short time that can cause new infections. Okay, so good question regarding alcohol being effective and why wouldn't you use that typically as I definitely would damage material. Again, it's only a surface needs to get penetrate the spores. So that, and also label use. I mean, it's not an approved fungicide. Yeah. You mean to actually spray onto the leaves as a... Again, I think you're going off label. So, yeah, I think too the amount you would have to use to get good coverage, I think would then really be detrimental to the plant. Yeah, so the question is, how does the spore actually get to the underside of the leaf? So it's either mechanically transferred, right? Something goes by, or a tool, and then goes near another leaf. It will travel in the water, so kind of that surface tension, it will just kind of spread and around, and oftentimes you'll see the first symptoms around the edges where the water accumulates. A lot of times then the material at the bottom, if you're not removing the infected leaves, the splashes start the process. So you'll oftentimes hear that, look for the symptoms in the lower parts of the canopy because it now splashes up. So the spore itself has that life expectancy, I guess, but as long as there's living material, is that what you're asking? Yes. The spore, I'm sorry, so the free spores themselves? Uh-huh. Probably due to heating up and the UV radiation, the spores on the surface, yes, would be dead at that stage. So the physiology, I guess, of the fungus and how the spores are too, the structures that they're produced on and well-protected internal spores. So it really does depend on the moisture, the overall environmental conditions, again, the temperature, how much UV radiation. The estimation is 6 months because it really does, it's an obligate that needs to get to a living host. So that's what the fungus, unless the leaf material is also degraded, you still have the potential to have the pathogen then produce more spores to find its way to the healthy material. Okay, so good question. The fungus, no, it will not, it's growing in the leaf, but it's not going to then go into the petiole and into the vascular system and then move throughout the plant. It's in there, will produce more spores, which then move around with the water, with the movement. Okay. So, you want to take, you can do. Thank you, everyone. And if you have more questions, please see me.
Thank you, Lisa. Lisa will be here for more questions, but we want to try and stay on schedule. It's a super important topic, so we let her go as long as we could. Next up, also from PBARC, Melissa Johnson will be speaking to Coffee Leaf Rust on Hawaii Island first-year insights from monitoring on commercial farms. Melissa. Oh, you're gonna scale the